Right, the first question on the review here says find the trigonometric ratios for the given triangle and simplify your fractions. So again, we just want to circle the angle, label the sides first. So if we notice, we're going to start with n. So we want to know the sine of n, the cosine of n, and the tangent of n. So I'm going to circle n here. Okay, 15 is your hypotenuse. It's across from the right angle, the longest side. And then across from n is the angle that we're dealing with is the opposite, and next to is your adjacent. So sine, again, so if we use SOHCAHTOA, or if you click on Schoology, under pretty much every day for the last 12 days, you'll have the picture of the different ratios. So sine is opposite over hypotenuse. The opposite over hypotenuse, that's 12 over 15. We want the simplify we want to simplify our fraction, so 12 over 15. The greatest common factor there is 3, so that's going to be 4 over 5. Okay. Cosine is adjacent over hypotenuse, so that's going to be 9 over 15. So I'm just going to write it down here so I have more room. So the first one was 12 over 15, which we reduced to 4 over 5. Second one, adjacent over hypotenuse, that's 9 over 15, which is going to be 3 over 5. And then tangent is opposite over adjacent, so that's going to be 12 over 9, which is going to be 4 over 3. Okay, and then we want to use p. We want to find the sine, cosine, and tangent of p, the ratios for p here. So we'll circle it. Hypotenuse stays the same. 9 is now the opposite, and then 12 is your adjacent. So sine, opposite over hypotenuse, so that's going to be 9 over 15, which is going to be 3 over 5. Okay, cosine is adjacent, 12 over 15, that's going to be 4 over 5. And then tangent is opposite over adjacent, that's 9 over 12, which is going to be 3 over 4. Okay, and so if we write those in there, right, we have 4 over 5, 3 over 5, 4 over 3, 3 over 5, 4 over 5, and 3 over 4. Okay, and that's it for number 1. You just write in the ratios, simplify the fractions. Okay, number 2, same thing essentially, except we're going to use radicals here. So let's start with angle F first, or angle M, which is F degrees. So F is your input. Okay, sine, again, if we put SOHCAHTOA back up, that might be a little above the screen, so SOHCAHTOA. Okay, so sine, we have opposite, adjacent, and hypotenuse. So sine is opposite over hypotenuse, so that's going to be 6 over 2 root 10. 6 divided by 2 is 3, so that's going to be 3 over square root of 10. And then to get the square root, get the radical out of the denominator, we need to multiply by square root of 10 over square root of 10. Okay, so that's going to be 3 root 10, right? 3 times square root of 10 is 3 root 10, and then square root of 10 times square root of 10 is just 10. And so that's going to be our sine. So 3 times the square root of 10 over 10. Okay. Cosine is adjacent over hypotenuse, so that's going to be 2 over 2 root 10. 2 divided by 2 root 10. Okay, so 2 divided by 2 is 1. So you have 1 over the square root of 10. Right, 2 divided by 2 is cancels out, so 1. And then you multiply by square root of 10 over square root of 10, right? We got to get the radical out of the denominator, so square root of 10 over square root of 10. So 1 times the square root of 10 is the square root of 10. Square root of 10 times the square root of 10 is just 10, right? It's the square root of 10 squared. And square root of 100 is 10. So that's our cosine, square root of 10 over 10. Tangent is opposite over adjacent. So 6 over 2 is going to be 3. 3 over 1, which is just 3. Okay. Right. Let's do for angle G. So hypotenuse stays the same. We switch the opposite and the adjacent though. 2 becomes the opposite, that's across. 6 is adjacent, that's next to. And we do them again. So sine of G, that's 2 over 2 root 10. Right, which is going to be the same as the cosine of f was. So we would divide, that cancels out. We get 1 over square root of 10. We multiply by square root of 10 over square root of 10. We're going to end up with square root of 10 over square root of 10 here. Okay. For sine, opposite, I'm sorry, that was sine. For cosine, adjacent over hypotenuse, that's 6 over 2 root 10, right, which was the same as our sine of f. So we cancel that out. It's 3 over square root of 10, and then multiply by square root of 10 over square root of 10. We're going to get 3 root 10 over 10. And then the only one that's going to be different is cosine. So cosine is going to be 2 divided by 6, which is 1/3. So 1/3. Okay, but notice how the sine of one angle is equal to the cosine of the other. The sine of f is equal to the cosine of g, and the sine of g is equal to the cosine of f. And then the tangent of f and the tangent of g are just inverses. So 3 over 1, 1 over 3. So that's just ratios in simplest radical form. Okay, next slide here. Okay, so if you're taking pre-calc or calc in the future, you should know these by heart. If you don't, that's okay. We have a table. So I have the table listed on Schoology there pretty much the last few days. Just go to Monday's day, today's day, and you just click on it and the table should come up. Right, but sine of 30, we got these from our special right triangles. Right, so we got our 30, 60, 90 triangle. So here's our 30, here's our 60. If we make that 1, right, our special right triangles rule, the hypotenuse is 2 times the short leg. The long leg is the square root of 3 times the short leg. And that's how we get all of these ratios. So the sine of 30 would be 1 over 2. The sine of 60 is square root of 3 over 2. Cosine of 30 would be square root of 3 over 2. Cosine of 60 would be 1 over 2. Okay. I'm sorry, cosine of 60 is 1 over 2. Okay. And then tangent of 30 is 1 over square root of 3. We multiply by square root of 3 over square root of 3. That's going to be square root of 3 over 3. And then tangent of 60, square root of 3 over 1 is just square root of 3, right? Opposite over adjacent. Okay, and then we can also do the special right, the 45, 45, 90 special right triangle. So if we have 45, 45, 90, if we make the legs 1, our hypotenuse is square root of 2 times the leg. And we can do the same thing. So sine of 45, right, that's 1 over square root of 2. Right, you multiply by square root of 2 over square root of 2. You're going to get square root of 2 over 2. Cosine 45 is going to be the same thing, 1 over square root of 2. So multiply by square root of 2 over square root of 2, you get square root of 2 over 2. And then tangent 45, 1 over 1 is just 1. Okay, but again, you can use the special right triangles, but also we're providing you the table. You can just look at the table for these. Okay, that's for 30 degrees, 45, and then for 60 degrees. All right, number 4. Okay, so we need to find the length of AB and the length of AC. So the distance from A to B and then the distance from A to C. So I'm going to make this X. Here. Let's solve for AB first. So this will be X. Make AB X. So circle the angle, label the sides. X is your hypotenuse. 3.5 is your adjacent. Okay, we have adjacent and hypotenuse. That's going to be cosine. So cosine of 55. Input the angle. Output is the ratio. So input into the cosine function is the angle. Output's the ratio. Adjacent over hypotenuse. That's 3.5 over x. Okay, we're trying to get x by itself now, so we got to get it out of the denominator. So we multiply x on both sides. We get x times the cosine of 55 equals 3.5. Got to get rid of the cosine of 55 from the left side, so we got to divide both sides by cosine 55. Okay, we put that in our calculator then, 3.5 divided by cosine of 55. So if we need to see that, we're going to come over here. All right, we're going to do 3.5 divided by cosine. We're going to make sure we're in degrees here. Cosine of 55. That's going to give us 6.1. Okay, round to the 10th place, that's going to be 6.1. So this will be 6.1. All right, now let's solve for AC. So let's call that y. Okay, we're still going to use the 55. Okay. Y here is your hypotenuse. AC is your hypotenuse. So we're going to use hypotenuse and adjacent. So I'm sorry, this is your opposite. I'm sorry. Y is your opposite across. We already got our hypotenuse. So y is opposite, 3.5 is adjacent. So opposite and adjacent is going to be tangent. That's the O and the A, tangent. So we have tangent. You input the angle. So our angle is 55, our input's 55, our output is the ratio. Opposite over adjacent, that's y over 3.5. Okay, we're trying to solve for y, so we're going to multiply 3.5 on both sides. So we need to do 3.5 times tangent 55 in our calculator. And just again to show you what we're doing, we can do it together. So that's going to be 3.5 times tangent 55, and that should be 4.9985. So we're rounding to the 10th place, so that's going to be 5.0. Okay. So that's going to be 5.0. That's why. Okay, and you can check your answer. You could try the Pythagorean theorem and check your answer if you wanted to. Right, so 3.5 squared plus 5.0 squared, does that equal 6.1 squared? If it does, then yes. If not, then you did something wrong. Okay, or we rounded a little bit, so it might be a little off, but essentially you can use that to check. All right, let's go to number 5. Okay, that was solving for sides. This one's solving for angles. So again, same process. You want to circle the angle. We're trying to solve angle A. We want to label our sides. 14 is your hypotenuse, 7 is your opposite, it's a cross. So if we're looking at SOHCAHTOA, we have opposite and hypotenuse, so that's going to be sine. We're using inverse sine because we're solving for an angle. So we input the ratio, opposite over hypotenuse, 7 over 14. And that's going to equal the measure of angle A. That's going to equal our angle. Okay, so we go to our calculator and we got to plug that in. Okay, so again, we want to make sure we're in degrees. Okay, we're in degrees. We're using inverse, so I'm clicking the inverse button. So sine 7 divided by 14, and that's going to give us 30 degrees. Okay, so 30 degrees equals the measure of angle A. Okay, if we're going for the other angle, okay, we can switch colors here. Okay, if we're trying to find the measure of angle B, our hypotenuse stays the same, but 7 is now adjacent to angle B. So we have adjacent and hypotenuse, that's going to be cosine. We're using inverse because we're solving for an angle. So inverse cosine, we input the ratio, and then the output is going to be our angle measure. So the measure of angle B. We go ahead and put that in the calculator. Make sure you're in degrees. Make sure you click inverse cosine. Put in 7 over 14, and that should give us 60 degrees. Okay, so we have 60 and 30. Okay, we know that's right too because we know that these two angles have to add up to 90. So we really, when we found 30, we could have just done 90 minus 30 is 60 because we know the sine of one angle, well, yeah, the sine of one angle is equal to cosine the other. I was saying that really wasn't the relevant point though. The relevant point was that these add up to 90. Right, those two should be complementary angles. All right, that's question 5. Let's go on to question 6 and 7 are the ones where you're going to have to draw. So 6, we got to start off with a drawing. So it says, a man stands at the top of an 80-foot lighthouse and looks down at a boat in the sea. If the boat is 4,000 feet from shore, what is the angle of depression that the man looks down at, round to the nearest hundredth of a degree? So today in class, I was trying to draw a lighthouse. Wasn't working out. So I'm just going to draw a building. That's going to be my lighthouse. Here's my lighthouse. Okay. A lighthouse. That's my lighthouse. It goes up. Maybe draw a staircase around it. No, 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 no. How do we go back? Can't go back. Yeah, we can. Whatever. Lighthouse. There you go. Okay, there's a man standing on top of it. So here's the man. Okay. And he looks down at a boat in the sea. So he's on the shore, right? The lighthouse is right on the shore. So here's the sea. Okay, and there's a boat out here. Okay, we've got a boat out here on the sea. Some of its bow is probably, or its hull is probably below. Okay, there's our boat. So he's standing at the top of an 80-foot lighthouse, so it's 80 feet tall. Okay, and he's looking down. If the boat is 4,000 feet from shore, what is the angle of depression that the man looks down at? So the angle of depression is the angle looking down. So let me first finish our triangle. Here's our right triangle. Okay, so he's looking down below the horizontal. So, here's our horizontal. Okay, so the angle of depression is the angle going down. It's the degrees to which he's looking down. So we can make another triangle here if we want to. And then this would be 80. This would be 4,000. But I think the easier way to do this is just use alternate interior angles. So if we can find this angle down here, that's going to be the same as this because these are alternate interior. and the ground is going to be parallel to the horizontal line up here. And since your lines are parallel, alternate interior angles are congruent. And so there we have our triangle. If we want to draw it again just to see it without all the fluff, you have 80 feet tall, you have 4,000 feet on the bottom, and we're solving for this angle here. So we want to use tangent, right? We need to circle the angle, label the sides. This 80 is opposite, 4,000 is adjacent, right? Opposite, adjacent. And so we're going to use tangent. So tangent of the angle, theta, right, is going to equal 80 over 4,000. Okay. So we notice we can't use regular tangent, so I started going down the wrong track here. We need to use inverse tangent to solve. So you could use this and do the inverse of both sides, but let's just do inverse tangent. Right, and in that one, we're going to input the ratio, 80 over 4,000. I know what happened. Number 6, we skipped number. How do we skip number 6? We hit it twice? All right. Inverse tangent, that's going to equal our angle. So we put that in the calculator. Okay, so you go inverse tangent, make sure you're in degrees, and that should give you an angle of, I believe, 1.15 degrees. 1.15 degrees. Down to the nearest hundredths of a degree. So apparently we skipped 7. Apparently we skipped number 6, but there's our answer there for number 7. All right. The OCD in me is not going to be very happy with this, but I do not want to do the whole thing over again. All right, number 6. I don't know how we did that. We must have double-clicked. So a ladder is leaning against the side of a house and forms a 65-degree angle with the ground. The foot of the ladder is 8 feet from the house. Find the length of the ladder. Right, so we have a ladder leaning against the house. So here's a house. No, that's fine. We got an upstairs window, we got a downstairs window. Got a door. There's our house, and then we got some ground out here. And here's our ladder leaning up against that house. Okay, again, it really helps to draw in 3D because, or 2D, I'm sorry, not 3D, 2D because it helps you figure everything out here. Okay, so a ladder leaning against the side of a house and forms a 65-degree angle with the ground. So here's the ladder, here's the ground. So the ladder forms a 65-degree angle with the ground. The foot of the ladder, so the bottom of the ladder, is 8 feet from the house. That's this distance here. Find the length of the ladder. Put an X there. So again, if you want to redraw the triangle without all the fluff, we have X, we have our right angle, we have 8, and then we have 65. So if we're solving here, circle the angle. This is adjacent, this is hypotenuse. So we're going to use cosine. So cosine, you input the angle, 65. Output is the ratio, that's going to be 8 over x. And we have to solve for x now, so we got to multiply both sides by x. And then we're going to have to divide both sides by cosine of 65. Divide both sides by cosine 65, cosine 65. And that's going to get x equals, and I don't remember this one, so let's do it together. We need to do 8 divided by cosine 65. 18.9 feet. 18.9. Oh, round to the nearest foot, that's going to be 19 feet. Okay. Number 8. Here. So let's look at number 8. Right, so we have to find the value really of w and x here, but we're going to need the height and we're going to need the value of w plus x, the whole base. So I like to call this z, instead of calling it x plus w, but that's fine. So I like to call it z instead of x plus w. Okay, but z is going to equal x plus w. Right, and we were looking for the height, so I'm going to call the height y. Okay, so first thing I'm going to do is I like to draw the triangle separately. I think that helps out tremendously. So I'm going to draw the two triangles separately. So I'm going to draw the big triangle here in green. I guess I'm going to draw them over here. Okay, so the big triangle is in green. The angle here is 32 degrees. We know this is 22, and we're looking for y, and we also have z as the bottom. And maybe we can do purple here, or the smaller triangle. So I'm going to draw that one over here. Angle is 50 degrees. And we're y, and then w. And we can't see all of that. Okay. Um, there we go. Okay. So first thing I'm going to want to find is the height of our triangles here. So I'm going to want to find the height of the big triangle and the purple triangle. They're the same. They're both y. So we can use the hypotenuse of the green one here, the big one, to find the y. So let's do that. I'm going to use the green for the green triangle. Okay, so circle our angle, right? Opposite and then hypotenuse. Okay, so we're going to do sine of 32. Actually, I take that back. Let's black. Okay, so this is opposite. This is hypotenuse. We're looking at the 32. So let's do sine 32 equals opposite over hypotenuse. That's y over 22. Right, and then we're simply solving for y. So we've got to multiply both sides by 22. So y is going to equal 22 times sine 32. If I remember correctly, that should be 11.65, which is going to be 11.7. Right, so we know the height here is going to be 11.7. So we can fill in for both of these 11.7. Now that we have that, we can find the base of both of these triangles. So we have the height for both. So we're looking for the adjacent on both of them. So if we have opposite and we're looking for adjacent, that's going to be tangent. So we can do tangent twice here. So I guess I can write them over here. Yeah. So, well, we'll write them down here, I think. So we can get one here. So let's do the first one here. So tangent 32. Well, I don't want to write it there. I lied. Let's do it here. Tangent 32 is going to equal opposite over adjacent. So it's 11.7 over z. Okay. So we're going to multiply both sides by z. Right, so we get z times tangent 32 equals 11.7, and then we can divide both sides by tangent 32, tangent 32, and we end up with z equals 11.7 divided by tangent 32 is going to be 18.7. Okay, so when you put that in your calculator, make sure you're in degrees, and you should get 18.7. Okay, the next one, so tangent of 50 equals 11.7 over w. So tangent of 50 is going to equal 11.7 over w. We multiply w on both sides. We get w times tangent 50 equals 11.7. And then we divide both sides by tangent of 50. Okay, and we end up with w equals 11.7 divided by tangent of 50 should be 8.9 if I remember correctly. Okay, and so therefore we have the base of all those triangles, the two big triangle and the small one. So this one will be 18.7, and then this one is 8.9, or is it 9.8? Hold up, it might be 9.8. Let me put it in the calculator, I don't remember. $11.7 divided by tangent of 50 is 9.8. It should be 9.8. Right? And then we can fill in here. So we know W, right, is 9.8. So we know this one here is 9.8. And we know Z here is 18.7. So if we want X, we're simply going to do 18.7 minus 9.8, which is going to give us 8.9. So this will be 8.9. So we know our height Y was 11.7. We know Z, which was X plus W, is 18.7. That's the base of the big one. We know W, the base of the small one, was 9.8. And therefore X is going to be 8.9 because 18.7 minus 9.8 got us 8.9. Okay. And then that's really it for the review. I have 4 extra questions for you guys to practice. So I suppose I can, I'll just end it there, and I'll make a different one for extra practice if you have questions on the extra practice.